Going on, guys? Let's see how we can find the volume of the region bounded by y square is equal to x and x is equal to 2y, and it's rotating around y-axis. So let's go ahead and draw the graph for these functions. So first of all, we have y square is equal to x. So whenever we had y is equal to x square, we drew graph like this, right? The parabola opening up. And if you notice in this parabola going toward the y positive direction. But here when we have x is equal to y square, this opens in the right direction and it goes toward x is in the x positive values. Like here we had y positive values, here is going to be x positive values. So that's the way we can make a connection for this. And also the second one is going to be a line, and if you rearrange this one, y is going to be equal to half x, and since this is positive, y is equal to positive value, that's going to be going toward this direction. So let's draw this one first. So this is going to go toward this direction, and the region we are interested in is this region, the region between them, right? So now we have two curves. So whenever we have two curves, we use this equation to find the volume. That is, v is equal to, since this is rotating around y-axis, we have to use this phi c to d outer radius square minus inner radius square. Since this is rotating around y-axis, we have to write everything in terms of y. So this is going to be dy, right? So let's see how we can find out outer radius and inner radius. To find the outer radius, when we draw a line from y-axis, if it's rotated around y-axis, we draw the line from y-axis. If it's rotated around x-axis, we draw the line from x-axis. So here we have this one rotating around y-axis. So we have to draw the line from y-axis, and when we draw the line from y-axis, wherever the line touches first, last, that's going to be the outer radius. So here it's touching this one last. So here we are going to have this as our outer radius. We know the function of this one, that is x is equal to 2y, right? This is x is equal to 2y, and inner radius is when we draw a line, whatever the line, whenever the line touches first, that's going to be the inner radius. So here the inner radius is going to be this one, function of this graph, that is y square is equal to x. We can write x is equal to y square, both the same thing. So here we need everything in terms of y, and x is already in terms of y, so we don't have to worry about changing anything. For example, if we had root x is equal to y, then we have to write this one in terms of x, and then plug the y value. Here we have to convert this into x is equal to y square, then we plug the y square for the function. But here it's already x is equal to y square, we don't have to change anything, we can directly go ahead and plug the values. So let's plug the values right here, phi, and we have to know the limits of integration. We know this is starting from 0, but we have to know the other limit, because we have to know the limits in y direction. To find the limits in y direction, what we have to do is we have to equate both of the y in these equations. So here we are going to equate y square equal to 2y. If we rearrange this one, this is going to be y square minus 2y is equal to 0. Therefore if I take y common, y minus 2 is equal to 0. Therefore we know that y is equal to 0 and y is equal to 2. So it's going from 0 to 2. So this is going to be 2, right? So this is going to be the limits of integration. And as we found out already, outer radius is the line touches last, that's going to be 2y. So this is 2y square, and inner radius line touches first, that's x is equal to y square. So here we are going to write y square square, right? That times dy, and now we can simplify this one. This is going to be phi going from 0 to 2. If we square this one, this is going to give us 4y square, and the other one is going to give us y power 4 dy, right? Now we can do the integration. If we do the integration, this is going to give us 4y cubed divided by 3 minus y power 5 divided by 5, going from 0 to 2. Now let's go ahead and plug 2 first. So if you plug 2, this is going to become 4 times 2 cube divided by 3 minus 2 power 5 divided by 5. Let's simplify this. So this is going to be 5 times 4 times 2 cube is 8. 8 times 4 is 32. 32 divided by 3, and the other one is 2 power 5. 2 power 5 also 32. So this is going to be 32 divided by 5. And here we can take 15 as our common denominator. If we take 15 common denominator, the top here is going to multiply by 5. 32 times 5 is 160. So this is going to be 160 right here. And then we have this one. So 3 times 5 is yeah, so here we have to multiply this one by 3, right? So this is going to be 3 times 32, that's going to be 96. 160 minus 96, and we have a 5 too, don't forget the 5, right? So let's simplify this one. 160 minus 96. 96 plus 4 is 100. So this is going to be 64 divided by 15, and we have a 5 right here. So this is going to be 64 5 divided by 15, and that's going to be the final answer. I hope you guys found this video helpful. See you next time.